Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on July 17th, 2025, so just 4 days ago. This paper introduces Balalaika, a new and very large Russian speech dataset that significantly improves the quality of text-to-speech models. The paper is titled A Data-Centric Framework for Addressing Phonetic and Prosodic Challenges in Russian Speech Generative Models, and the results really highlight the importance of good data. It tackles the unique difficulties of Russian, like its complex stress patterns, to create more natural-sounding AI voices. Also, the authors shared their entire framework on GitHub. In the Balalaika repository, you'll find everything to get started, from scripts to download and prepare the dataset to the full processing pipeline itself. It covers transcription, accent restoration, and phonemization, with detailed instructions to guide you through it. Alright, so this first figure visualizes their entire annotation pipeline, showing how they go from a raw audio file to a fully enriched data point. It starts with Whisper v3 large to segment the audio. Then, a model called Niska-S assesses the quality, predicting a mean opinion score to filter out bad recordings. After that, they add transcription and those crucial stress marks. Next, a grapheme to phoneme process, which converts the text into its basic sound units, gets aligned with the audio. Finally, they identify speakers, resulting in this incredibly detailed output. Moving to the results, this next table shows just how effective that data pipeline is for a task called speech restoration, which is basically using AI to clean up and enhance degraded audio. They took a model called SE Mamba and trained it on their new Balalaika dataset, shown here as ours. The table compares it against other models using various metrics. The most telling one is the manual mean opinion score, or MOS, where humans rate the audio quality. And their model achieves the highest score, showing people found its restored audio significantly clearer. Building on that, this next table really gets to the heart of why their models perform so well. It directly compares the quality of their new Balalaika dataset against other existing Russian speech datasets. You can see their dataset, labeled as ours, at the bottom. It's evaluated on several metrics, including automated quality scores like Niska and UTMOS, and that crucial manual mean opinion score. The highest quality part of their dataset achieves a manual mean opinion score of 4.593, which is significantly higher than any other dataset listed here. So this next table shows how that superior data quality translates to a key application: text-to-speech synthesis. They trained a model on their new Balalaika dataset, listed here as ours, and compared its performance against models trained on other Russian datasets. Looking at the manual mean opinion score, their model again comes out on top. It does score second best on the intonation mean opinion score, which is a specific rating for how natural the speech's melody sounds, but the authors note the top scoring dataset there is single speaker, making intonation an easier problem to solve. Okay, so we've seen how their data helps create natural-sounding speech. But what about cleaning up existing audio? This next table looks at a task called speech denoising. Here, they trained the same model, SE Mamba, on all these different datasets and tested how well each version could remove noise from a recording. The performance was measured using a whole suite of automated metrics, which test for things like clarity, lack of distortion, and intelligibility. And once again, the model trained on their high-quality Balalaika dataset, that's the bottom row, consistently outperforms the others. So we've seen the full dataset excels at these tasks, but what makes it so effective? This next table answers that with an ablation study. That's a process where researchers remove components one by one to see what impact each has. Here they tested their text-to-speech model with their dataset minus punctuation, minus stress marks, and then with both included. And the results are clear. The bottom row, which uses both stress and punctuation annotations, performs the best across the board, achieving the highest human-rated quality scores and the lowest character error rate. So we've seen the full dataset excels at these tasks, but what makes it so effective? This next table answers that with an ablation study. That's a process where researchers remove components one by one to see what impact each has. Here they tested their text-to-speech model with their dataset minus punctuation, minus stress marks, and then with both included. And the results are clear. The bottom row, which uses both stress and punctuation annotations, performs the best across the board, achieving the highest human-rated quality scores and the lowest character error rate. So that ablation study really drives the point home. In the end, this work makes a powerful case for a data-centric approach. By creating the Balalaika dataset, with its high-quality audio and detailed linguistic annotations for things like stress and punctuation, the researchers were able to significantly boost performance on a range of challenging Russian speech tasks. It really highlights that for complex languages, simply having more data isn't enough. The quality and richness of that data is what truly matters. Alright, that's all for this episode of the AI Research Roundup. Thanks for tuning in.